Okay, so in the last video I turned on the inverter connected to the battery pack and I was getting errors. So I started doing some debugging and there's a couple issues. So the inverter looks like it runs at a 96k baud or 9600 baud rate. The BMS seems to be 115200, at least the setting I was on. I found a setting in there that runs it down to 96, the same baud rate, and I tried it and kept having issues. I contacted the manufacturer and they more or less said it's my cable, it's a problem. Yeah, I doubted it because I was pretty good at, not my first time making cables. So I made a second cable, still same error. So then I just said, okay, let me do a USB to RS485 adapter, and I'm able to talk to the BMS through the computer. But when I connect it to the inverter, I get nothing but garbage output. So I'm not getting communication out of the inverter. So then it errors out. I've put a scope on it. The scope shows lots of noise. It just doesn't look like a good signal. So I'll show that setup. What I effectively did. Let's make sure that's square. So I've more or less, I have this USB inverter, or USB to RS485. This ends another RJ45. I've looked inside for the pin maps, or the pin colors, and I traced them out and then basically connected A to A, B to B. And I can connect to the battery pack. But when I do the same thing on real term, set to the right settings, I get nothing but garbage. I'll show that here on the screen. Okay, so now on this, what I'm doing for a test is 3 of the 4 panels I have hooked in series. They're outside, out there. I got extension cables and I ran them into here to this disconnect. Since the video 2, I've also wired the disconnect up here in the corner to the inverter. So I have a disconnect there because this one will go outside in the long run, so I can shut it down outside, and then this one's in here to shut down on the inside. I went ahead and made this cable for testing. It's basically the MC4 connectors and then 2 furls so I can put them in. But before I just go connecting them up, I'm going to connect it, turn that switch on, and verify I got verify plus and minus before I actually connect it to this side and give it the full send, because I don't want to do something wrong. So let me pull the pack out. What I've also done too is since we're starting to get a lot of colors, show, marked them here with tape, here and here, so you know that the pink one is for the solar feed. The reason I went with pink is I use all the other colors for the phase markings of other stuff, and this is what when you buy the pack of tape, this is just the leftovers, or that's not used for like, oh, I need to go mark a white for neutral when you have 3 of the same color lines. So that's just to keep track of it, and I had a lot. So let's go ahead and get my meter. And let's go ahead. We're going to put this to DC. So in theory, I have nothing. Let's verify. Let's go positive into the red. So nothing, and there we go. I got let's see if I can hold this up to the camera. 100 volts DC, but it's, oops. Oh, I pulled the red out. Let's try to hold that. So you see we have 100 volts DC, but it's negative. So polarity on these cables is swapped. The MC4 connectors only go one way, so in order to well, some of these are also extension cables. The extension cables I bought off of AliExpress, so they could have made them backwards. But these are the ones that match up to the they only go into the panels one way, as you can see right here. The panels have these ends on them, so you can't, I mean, I can go this way into each other, but the panels connect in series to that. So I just relied on what that is. So I have two options. I can open up this and redo this inside to match it, so that I guess switch it in here so red here is correct. But for now, what I'm going to do, let's turn this off, is we now know it's backwards. So I'm going to put it on here and then connect it, make the switch here at this end before it goes into here. This side, I actually marked with red heat shrink, and I follow the heat shrink mapping from here to here. So this is positive to positive, negative, negative. And for these testing purposes, I did, for testing purposes, this is SO cable. So I just clipped, it's the AC SO cable, and I just clipped off the green, so it was stubby. So I'm going to go ahead and get this verified. I have all my stuff off so I can touch everything, and then we'll turn it. I'll hook up the BMS and limit the power intake of the BMS, and then we'll go ahead and turn this guy on and see what happens. Or I might just leave this off for now because the kill switch is off, and that way this comes on. We're not going to push any power into here. We'll go through the settings here. It's still set to talk to RS-485, so I'll have to go in and adjust that, or else this inverter will error out after, like, I think it's 20-30 seconds. So let's go ahead and get that set up. Okay, verified off. Just as a sanity check to make sure my cable's still good, I'm going to measure these with the meter real quick. I need to apply power, so that's back on. And verify I have power. So white in this case will be positive. Verify. Yeah, and it just so happens to line up that they're backwards, but this color scheme matches this color scheme. So I'm going to go ahead and kill this. We know white's positive. Okay. Okay, so now that's hooked up to here. Cool thing is these metal terminals here are exposed. So I have the last opportunity to check it. So what I'm going to do is apply power. So now I should have power to here. And before I flip this switch on, I should have the ability to flip it before I can turn this on, because I can touch the ring terminal. So let's go ahead and do that. Verify that positive, negative, negative, and 100 volts DC. So I think we're good. Well, here comes the fun part. Battery's off. Let's oh, there it goes. Error 58, so I don't know what that means. Okay, so what it's saying is output voltage too low, and I think that's referring to the battery. So that makes sense because this is off. So I'm trying to think. Let me get my BMS. Let me get the BMS thing hooked up first, so we can watch the BMS on the computer, and I'll put that on screen, and then we'll turn things down so we can see what's going to happen. Well, before we do that, let's go put this inverter to just lithium mode, not lithium with RS-45, since we know that doesn't work at the moment. Battery, hopefully you can see that, it says lib for lithium RS-45. We're going to enter that mode, we're going to change it to just, oops, where is AGM, flooded, user, lib. So now it's just on lithium battery only. Okay. Escape. So let's turn the solar off. Let's turn the battery back on. It's going to boot up. Let's make sure this is going to work. Okay. Let's swap dashboards on this screen record. So we're pulling about things pulling about negative 80. I guess there goes nothing. Oh, cool. It's now seeing. I'll move the camera so we can see this better. So here we go. We have our battery. It's showing the charging. Man, this guy's a reflection on that. Our output 100, and I wonder if there's a way to switch menus. I gotta play with this more. So clearly we're charging battery. Looks like we're pulling about 5 amp in, according to the dashboard. I believe that's what that says. So, is there a watt input? I'll look for a watt input calculation. Well, let's see, what if we go, hey, oh, what does this get us? Don't know what that means. Battery, 26.3, okay. No load, nothing's hooked up. It thinks it's pushing 7 amp, 6 amp. Inverter thinks it's only doing, could be that it's just a conversion from high voltage to low. So let's, not sure how I can, oh there it goes, 5, 26, 1. Yeah, so the current thinks it's 5, this thinks it's 7. But just calibration issue, let's see what else we got. Pulling 141 watts in. Well, it's something. It is also 4:30 in the afternoon in Arizona, so, and the panels are in, most of them in sunlight, part of them are in a little bit of shade, so that could be, I'd expect to see this kick up. I'll do an update video thing tomorrow during the day, and we'll see what happens when we go during the day. We're doing it. So pulling in around 2 amps, that's good, I guess. Oh, voltage is dropping. Let's see if this thinks it's 91 volts. Let's measure it with the meter and see what the meter thinks we're getting. Okay, so this thinks it's 89.9. This thinks it's 90.91. Which, when we started, we were on 100, so we've lost 10 volts, so. I go positive here where it's, yeah, give me, yeah, I'll go here. Yeah, so it's reading 90 flat, 88, 8, 89, 7, so it's bouncing around a little. My guess is the MPPT is doing its thing and we're seeing drifting as it's pulsing. Oh, input 0. Why'd it go to 0? I guess it's the MPPT switching. And I don't know what this means. I'll have to figure out what this screen means. It looks like it's goofy. So it thinks it's 0 now. That's odd. But the meter says 90-ish. Okay, so I'm going to let this run for a little bit to bring this up. The BMS thinks the battery is in the, I think it's 64%? Yeah, 64%. Since I'm probably only getting a little bit of, oh, that's, why is it switched to ACE? Oh, it might be an auto timer, and that's why the screen's changing. Maybe there's a way to program it so I can see what I want. I'm gonna have to dig through this manual. It's not the best. Hi, Penny. Hi, baby. Who's a good girl? I'll have to switch through this. Let's see. PV 9 volt. Okay, 2 amp. So input 141 watts. It's gonna take a long time at 141 watts to hit to bring that battery up. Hey, move, get out, move. Good girl. Okay, so I have the settings here. So I'm gonna go through and we'll configure this. Like I said, we're putting in, oops, let's like the computer back up so you can see the screen. Keep an eye on the battery. Alright, so we're pushing around 3 amps into the system. And, or it looks like 81 watts according to BMS, so let's go through this. Okay, well, I need to make some more tea, which requires boiling water. So what more of a test should I do than, let's see if this will run an electric kettle. I have to grab a cord over here. It's slightly longer since this, oops, since this is too short to hit there and it's gonna have water in it. So yeah, let me adjust the camera. And then I'll make sure to screen record. Full of water. I'll put it this way. Now let me start recording on the BMS side. Okay, we're recording. Let's see how much current we pull. Oh wow, 60 amps. %, load. 1.6 kilowatt. Move, Penny. or so of hot water and 4 tea bags to make tea. Let that cool, fill the rest with water, throw it in the fridge.